Hello everybody, today we're going to be looking at the M coloring problem. So we have a graph and we want to color every vertex in this graph, but we want to make sure that no two vertices which are adjacent have the same color. So for example, this is a graph which is properly colored. No two adjacent nodes have the same color. So we want to be able to detect if this is possible and what that coloring is for any given graph. So this is the algorithm to do that. Basically, we start by defining our graph, and then we define what colors we're allowed to use. So that's usually some integer m. So I'm going to start with m equals 2, which means we have two colors we can use. Whatever, red and green or whatever. I'll just call it color 1 and color 2. And then we also have this matrix, which is our color array. And, or sorry, our array, which is our color array. And it has the same number of elements as there are nodes. So there's 5 nodes here, so there's going to be 5 elements here. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And each value will get the color of that node in this graph if it is possible to color with 2 nodes like that. So yeah, let me just move this graph down a little bit. Okay. So the algorithm works like this. We start at our node 0, and we give it just the first color. Either it can be color 1 or color 2. So let's say we're going to give it color 1 to start with. And then you move on to the next node, and you ask the same thing. Can I give it color 1, yes or no? Can I give it color 2, yes or no? So let's see what happens if you can. So for the first one, we can give it color 1. There's no issues. Nothing else has been colored yet, so it can get color 1. Move on to the next node here. Can we give it color 1? We can't, because this node already has color 1. So we have to give this, well, we can't give color 1. Can we give color 2? Yes, we can. No other adjacent nodes have color 2. Great, we move on. Node 2, can we give it color 1? We cannot, because of this node. Can we give it color 2? We cannot, because of this node. Okay, we need to backtrack now. So I backtrack back up to this node here. Any other colors to give? No, there's no other colors to give. So I backtrack again. Any other colors to give? Yeah, we could have given this 2. We start again now. We're back at node 0, but this time we give it color 2. So now we're going to go to node 1. Can we give it color 1? Yes, we can. Now we're going to move on to node 2. Can we give it color 1? No, we can't. Can we give it color 2? No, we can't, because of this node and this node. Once again, we backtrack. Can we give this color 2? We cannot. Once again, we backtrack. Any other colors to give this one? No. So the answer is return. The algorithm will return false, meaning this graph cannot be colored using only 2 nodes. The 2 different colors, I mean. But what if I set that number to 3? Let's try. So setting that number to 3, okay, same process. We're going to start with node 1 here, node 0. Give it color 1. That's fine. Move on to node 1. We just do the nodes in order. So move on to node 1. Can I give it color 1? Nope. Can I give it color 2? Yes, I can. I can give it color 2. Move on to node 2. Can I give it color 1? No. Can I give it color 2? No. Can I give it color 3? Yes. Because remember, now we're doing colors 1, 2, and 3. So I can give it color 3 now. Great. Now move on to node 3, right? Because we're going in order. 0, 1, 2, 3. Can I give this node color 1? No. Can I give it color 2? Yes, I can. I can give it color 2. Because there's no other adjacent node that has it. I move on to node 4. Can I give it color 1? Yes, I can. And we're colored. So the coloring is color 1, color 2, color 3, color 2, color 1 for this graph. And so as you see here, no adjacent nodes have the same color. Every pair that are neighbors have different colors in this graph. So it's a backtracking algorithm. You kind of just go through all the options. It's very similar to the rat in a maze problem, except instead of choosing 2 directions, we just choose different colors and then we move to the next node. Okay, that's all for this one.